9.2 Getting your data up to shape. How to visualize data. Napoleon conveying data. Visualizing data can date as far back as 1861, when a man named Charles Joseph Menard was able to display Napoleon's thematic map of the 1812 invasion and retreat of Russia. In the diagram, we can see the size of the army, locations of troops, and various temperatures during that time. This diagram is known as one of the best statistical graphics ever drawn. Thankfully, visualizing data nowadays does not need to be nearly as artistic and fancy. Overview of visualizing data. A good visual representation of data should reveal patterns and relationships among the data. Graphs can show important features of the data, such as where it is centered, whether the data is clustered or spread, outliers, etc. Organizing the data in a visually informative way allows us to see arithmetical concepts of shape, center, and spread. Many ways to visualize data include line charts, bar charts, pie charts, histograms, stem and leaf plots, and more. The pie chart. Pie charts are helpful in describing how resources are divided. It is easy to see the sizes of data collected. Pie charts should be used to show percentages or proportional data represented by categories. By looking to the chart to the right, we can easily notice that 35% of students prefer pizza, while 8% prefer salad. Stem and leaf plots. Stem and leaf plots are useful to display the shape of the data showing the distribution. Stem and leaf plots are also helpful in determining any outliers in a data set. It gives you a visual sense of where data clusters while also being able to see all individual values from a data set. To the right is an example of a stem and leaf plot showing ages. From the key, we can determine what these numbers mean. If a stem is 2 and a leaf is 9, the age is 29. Histograms. A histogram is a graphical display of data using bars of different heights. Each bar will fall into a range or interval. The taller the bar means that the more data falls into that range. A histogram differs from a bar chart as histograms show distributions, not compare variables. Histograms are also quantitative data versus a bar chart being categorical data. Bars touch as well in histograms. Histograms are a good method to see data within different ranges. Shapes of histograms convey the distribution of data. Choosing the size of the intervals is important as it is also showing the shape of the data. Mindscape 1. A survey of 23 people who had home access to the internet and how much they paid is listed below. Make a histogram of the data on the cost of internet access using the intervals 0 to 4, 5 to 9, 10 to 14, and so on. Describe the distribution of values in words. The histogram above indicates that the distribution of values is most commonly ranging between $15 and $29, explaining that most people have paid around that range for the internet access, considering how high the frequency is within those intervals. Averages of center, mean, and median. The most familiar way to summarize data is referred to as a measure of center. Some may think of an average, but the mean and median is what we actually want. The mean is a sum of data divided by the data points, while the median is the middle data point where the data is in numerical order. They are both useful summaries of values in a given data set. Measuring the spread and standard deviation. One method to measuring the spread of data is computing the mean. A more complicated way to measure the spread is standard deviation. Standard deviation tells us how far the average data point differs from the mean. The greater the spread of data, the larger the standard deviation, and the more tightly clustered the data is around the mean, the smaller the standard deviation. Mindscape number 2. Remember that standard deviation measures how far a typical score is from the mean. However, for the set of exam scores below, if you are told that the standard deviation is either 2.7 or 10.3, which one must it be? Explain why. Given the data below, the standard deviation of this dataset must be 10.3. The mean of this dataset is 87.4. 10.3 is correct because the numbers given in the data are more spread out and not as close to the average or mean. If the data was more clustered around the average of 87.4, the standard deviation would then be 2.7, but due to some outliers, the standard deviation goes up. In conclusion, graphs typically show the shape of data. The mean and median shows summary of data. Standard deviation gives a numerical measure of spread. And all of these are very helpful in describing and displaying a data set, and visualization of data is very important within the process. Thank you for watching.